Our next lesson is called Application of Systems of Equations. So we'll start with the opening exercise. It says, during the 2010 season, football player McGee's earnings, M, were $0.005 million more than those of his teammate Fitzpatrick's earnings, F. The two players earned a total of $3.95 million. Which system of equations could be used to determine the amount each player earned in millions of dollars? So you have four options there. I'd like you to pause the video and try the opening exercise, and then resume the video when you are ready to go over the answers. Okay, so you had a chance to try the opening exercise on your own. I highlighted some important information that I thought you should use to help you do this. The first piece of important information is that McGee, M, is $0.005 million more than his teammate Fitzpatrick. So what that really means is I have to take Fitzpatrick's earnings, add $0.005 million to it, and then I'll get McGee's. So that's what you see the equation M equals F plus 0.005. Now, in addition to that, we know the two players earned a total of $3.95 million total. So that means M plus F should be equal to 3.95, which means that choice D is the correct answer. Now let's move on to example 1. Lulu tells her little brother Jack that she is holding 20 coins, all of which are dimes and quarters. They have a value of $4.10. She says she will give him the coins if he can tell her how many of each she is holding. Using a system of equations, solve this problem for Jack. Now, when solving a problem like this where you have a certain number of items and then you have information about their value, that's what guides you through writing your two equations. So in number 1, you want to make sure your first equation has the total number of items, and that pertains to any question that's set up in this form. And your second equation is going to come from the total value. Now, in our situation, our total number of items is the total number of coins. And according to our problem, we have 20 of those. Our total value in dollars is $4.10. They would like us to know the number of quarters and the number of dimes, so I need a let statement for each of those things. So let X equal the number of quarters, and I'll have Y equal the number of dimes. Now we can write our equations. First equation comes from the total number of coins. I'm holding dimes and I'm holding quarters. So all of my quarters plus all of my dimes should be a total of 20 coins. The next equation brings in the value. No matter how many quarters I'm holding in my hand, each quarter is worth 25 cents. So if I had 2 quarters, that'd be 50 cents. If I had 3 quarters, that'd be 75 cents. So you're going to take the value of a quarter, which is 25 cents, and multiply it by how many quarters you actually have. With the dimes, you'll do a similar thing. It's just that dimes are worth 10 cents for a total of $4.10 overall. So I'm going to use elimination method. I need to eliminate one of my variables. I'm going to choose to get rid of my y. So I'm going to multiply this top equation by a negative 0.1, distribute it through, which will give me a negative 0.10y, which I can eliminate and add to the other y's. So my new equation is negative 0.10x plus a negative 0.10y, or you could have just done instead a subtraction symbol, is equal to negative 2, and then my second equation stays exactly as it is. Now when we add these together, I end up with 0.15x. My y's are eliminated, and I have 2.10. I can divide by 0.15, and x is equal to 14. So I know I have 14 quarters. Using the equation x plus y equals 20, and you can use either one. I'm choosing the one that's easier to use. I'm going to find my other variable y. I already know x is 14, so I will plug that in. Now I'll subtract 14 from both sides and get that y is equal to 6. So I have 6 dimes. All right, now let's look at example 2. Franco and Carol went to a bakery to buy desserts. Franco bought 3 packages of cupcakes and 2 packages of brownies for $19. Carol bought 2 packages of cupcakes and 4 packages of brownies for $24. Let x equal the price of 1 package of cupcakes and y equal the price of 1 package of brownies. They want us to write a system of equations that represents or describes the given situation. We're going to graph it, and then we'll go from there. So when I'm looking at this, I see information that's important. I see Franco bought 3 packages of cupcakes and 2 packages of brownies for $19. So that's my first equation. They said cupcakes was x, and they have brownies as y. So they already gave me a let statement. I know what to use. So my first equation should be 3x plus 2y equals 19. I also got a second piece of information that Carol bought 2 packages of cupcakes and 4 packages of brownies for $24. So that equation would be 2x plus 4y equals 24. So that's the system that we are now going to get on this graph below in order to see if we can figure out the solution and find out the price of a package of cupcakes and the price of a package of brownies. Now, looking at this graph, I don't see any values. So we need to take a look at this ourselves. It said that x was the price of cupcakes. So on the x-axis, we will write price of cupcakes. And we'll reposition that a little bit. And then we will also write on y, price of brownies. Now, of course, this is a first quadrant graph because we're not going to have negative values. So this point right here should be 0. And then before I decide my scale, I want to actually go over and put my equations in y equals mx plus b form, which is slope-intercept form, so I can see what values we're working with, and so it'll give me a better indication of what I should go by on my graph to make sure that I'm able to plot all of the points necessary to complete the picture. So we'll start with 3x plus 2y equals 19. We want to get y by itself, so first we move the x's away by subtracting 3x from both sides. So 2y equals negative 3x plus 19. Just gonna move this over a little. I don't want 2y, I want 1y, so I'm going to divide every piece by 2. And I get y equals negative 3 halves x plus 9.5. Now you can make negative 3 halves negative 1.5, of course, that's numerically possible, but doing that in a problem where I'm graphing is not helpful to me. I want to use the slope as rise over run, so making it a mixed number is not going to help me, so I suggest you leave it as it is, as an improper fraction if necessary, okay? Because from here, I can identify that the slope is negative 3 halves, which means I'm going down 3 to the right 2, and my y-intercept is 9.5, which means the first point that I plot is 0, 9.5. Then we'll also get the other equation, 2x plus 4y equals 24, and y equals mx plus b form. First, we're going to move the x's away, so we'll subtract 2x from both sides and get 4y equals negative 2x plus 24. I don't want 4y, so I'm going to divide every single piece by 4, the coefficient of y. to get y equals, this would be negative 1/2 x, I can reduce, plus 6, which means my slope is negative 1/2. I'm going down 1 to the right 2. And my y-intercept is 6, which means the first point I plot is 0, 6. Now that I'm seeing this information, as long as I get to 10 on each of the x and y axes, I'll be good to go. So let's see if we can do that. If I take a look at the scale, I have enough to make every box worth 1, and that way we can get all the way up to 10. So if every box is 1, we don't have to mark every single one. We'll put 5 here, and we'll put 10 here, and then we'll put 5 here and 10 here. So now we'll start with our first line, starting at 9.5, would be halfway between 9 and 10, and we are very carefully going to go down 3. So 1, 2, 3 would be here. 2 to the right is going to be right here. So be very careful with halves that you're counting appropriately. Okay, so we'll do it again. 1, 2, 3 down to the right 2. 1, 2, 3 down to the right 2 puts you there. We will then connect it, and we'll think about this. This is a real life situation where we don't want negatives. So I'm going to stop as soon as I run into the x-axis. I should not be going past that. That's actually an endpoint. There should be no arrows on this line. It does not make sense in the real life situation that we are working with. Make it a little thicker so you can see it better. And we will then label it with its equation, 3x plus 2y equals 19. Remember, you're labeling with the original. We will now switch over and graph the other one. We're starting at 6. We are going down 1 to the right 2. Down 1 to the right 2. Repeatedly. And this time when we draw this one in, there should be no arrow over here. But when we look at this picture, in the snapshot that we have, it's still going to go a little bit further before it runs into the x-axis. So we will, again, make this line a little thicker so you can see better where it should be. Oop, did not mean to do that. Okay, we'll make it a little thicker. This time, though, there should be an arrow on this end because it technically is going to hit the x-axis somewhere off of our little snapshot picture. Okay, and then we're going to label this with 2x plus 4y equals 24. Now, normally the solution is where these intersect. So here's where they intersect. You tell me, can you tell the exact location of that? The answer is no. I'm going to put a bunch of big question marks here. So this is why we need more than one method for solving a system. Graphically is not the best option for a problem like this. You would be estimating to try to get this correct. So now we're going to go back and talk about the fact that we need the exact cost of this package of cupcakes and this package of brownies. So in order to do this properly, I'm going to highlight a couple keywords. We need exact, and it says to justify my solution. So the only way I'm going to get exact is by doing it algebraically. And to justify my solution, I'll just show my work. So my system was 3x plus 2y equals 19 and 2x plus 4y equals 24. So I want to be able to solve this. So I'm going to use elimination method since they're both in standard form. I'm going to make opposites by multiplying this top equation by a -2. Because what that will do is give me negative 6x minus 4y equals negative 38 when I multiply everything in that first equation by -2. And I'll keep my original 2x plus 4y equals 24 underneath. That way, when I add these together, negative 6x and 2x is negative 4x. My y's totally eliminate, hence elimination method. And negative 38 and 24 makes negative 14. I would then divide both sides by -4 to get that x is 3.5. I can then go back and pick either equation I want. So I'm going to pick 2x plus 4y equals 24. I'm going to plug in what I already know, which is x. So that's 3.5. 2 times 3.5 would give me 7, plus 4y equals 24. So I would subtract 7 from both sides to get 4y equals 17. And then to get y alone, I would divide by 4 and see that y is 4.25. So now I know that one package of cupcakes costs $3.50, and one package of brownies costs $4.25. So the important lesson here is that we really need to think about which method is best given the situation. And sometimes you might run into a problem where you have to switch methods. So that concludes your lesson on application of systems of equations.